So for exercise 5.4.7, they're asking us which method we're gonna use to solve some integrals. So the first one that I chose was A, which is the integral of x squared times the cosine of x cubed dx. So for the method that we're gonna use is use substitution. So why? Because here we can see that x cubed is inside another function, and that can be our u value. So our u value is gonna be x cubed, therefore our du value is gonna be 3x squared dx. Notice that our value of du, which is this, doesn't cancel completely with the value that we have outside of this that is multiplying this function. So what we're gonna do is move this 3 to this side, so it's dividing. So we know that 1/3 du is equal to x squared dx, and now we can cancel the x squared that is here outside. So now that we have all the x in terms of u, we can substitute them for u's. So in this case, this 1/3, we're gonna put it outside of the integral because it's a constant. The integral of cosine, we don't put the x squared no more because it's canceled. Cosine of u du. And then if we solve this integral, du disappears when you integrate, so the result is going to be 1/3 sine of u plus c. So the final step is just substitute the u value for its value of x. So in this case, u is equal to x cubed, so we just substitute u for x cubed. So this is going to be our final result. Now for e, we have the integral of x cubed times the sine of x to the 4th dx. So in this case, we're gonna do the same thing that we did for a. So our u value is gonna be x to the 4th because it's inside this function of sine of x. So if u is x to the 4th, we know that our du is 4x to the cube. So now if we leave alone our dx, we know that du divided by 4x thirds is equal to dx. And this is also equal to 1/4 times du divided by x cubed. So if we substitute this to our integral, we can take out this constant outside. And notice that here x cubed cancels with this one. So we'll only get this function which is 1/4 sine of u du. So now if we integrate it, we get negative cosine of u plus c times 1/4. And then the last step that I mentioned before is to substitute the u for its value of x, which in this case is x to the 4th. So for the last one, we are going to use both, use substitution and integration by parts. So for the first step, we're going to use substitution. And now we're going to choose our u, which, if you have noticed, it's going to be x to the 4th because it is inside this other function, which is sine of x. So if our u is x to the 4th, we know that our du is equal to 4x to the 3rd. And if we leave alone our dx value is going to equal to du divided by 4x to the 3rd. Now we can substitute those values respective to their x function. So if we substitute, all this is going to be the integral of x to the 7 times sine of u times du divided by 4x cubed. So notice that here this is the same thing of 1/4 times du x cubed. So we can take out that constant and can divide x to the 7 by x to the cube, which is gonna give us x to the 4. And as we mentioned previously, that u is going to equal to x to the 4. This function is going to be equal to this one because we just substituted this value that we just obtained by its value of u. So we obtain 1/4 times the integrate of u times sine of u du. So at this point, we need to use integration by parts because we will not be able to solve the integral if we substitute the u for the x function. What I mean with this? So notice that if we want to right away substitute the u value by x to the 4th, we obtain this function, which is very hard to integrate. So for our purposes, it's more convenient for us to leave it like this and use integration by parts as it looks like here. So since we're already using that constant u, we're going to use, in this case, w. So it's the same formula, but we just change the variables so we don't get confused. So the formula of integration by parts is this one, but notice that here we have a 1/4 because our previous integral was multiplying by 1/4. So first thing is choose our values. So for our w function, we're gonna use u, and for our dv, we're gonna use sine of u. So if w is u, we know that dw is gonna be just du. And if our dv is sine of u, we know that the v is negative cosine of u. Now that we have all these variables, we can go ahead and substitute it in the function. So w is u, dv is sine of u, du, which is gonna equal to 1/4, well, because we're multiplying by 1/4 from here, times w, which is u, times v, which is negative cosine of u, minus the integral of v, which is negative cosine of u, dw, which is just du. So when we integrate this, du cancels, and we obtain negative sine of u. And here's the negative side, so it's going to be a positive sign. So the function already integrated in terms of u is going to look like this. So now we can solve the integral. The last step is to change the u values for the x function values, which it was x to the 4th. So we just changed our u for x to the 4th, and this is the result.